Hello everyone and welcome to the coding branch. In today's episode, I'm going to be introducing you to the basics of JavaScript. Don't let programming scare you. Learning a full stack may seem like a lot, but the key is learning one thing at a time. Though, if you are going to be getting into full stack, JavaScript is a great place to start. JavaScript is so easy a caveman can do it, and you can leverage your JavaScript superpowers to build awesome applications. So let's get right into it. I'm going to be going over everything you need to know to get started in building small programs with JavaScript. As usual, if you'd like access to the code, there will be a link in the description below. I'm going to be showing you in a second, but we're not going to be running JavaScript in the browser. I think it's easier to learn the fundamentals when you can use it like a scripting language. So, we'll be using Node to run a simple JavaScript file. If you're unsure what Node is, check out my video on how to run JavaScript locally. Other than that small piece of knowledge, I'm assuming you know nothing about JavaScript, so anyone can watch this video. Though, if you have any experience with any other programming language, they should all make sense. Okay, so you all know we live in a data-driven world, and that data needs to be stored somehow. In some cases, it'll be in a database, but when using JavaScript, you'll be storing different types of data in what are known as variables. Variables can be named most anything except for a few key words, but it is important to name them with a self-descriptive name so making sense of your code is a lot easier. To create a variable, you type var, follow it with the variable's name and what it's equal to. Though JavaScript is very forgiving, there are a handful of different data types. The first is a string. A string must be stored in quotes. Though JavaScript doesn't care if you use a single quote or double quotes, I tend to use double. A string can contain numbers, letters, and any type of keyboard characters. Think of it as a statement, if you will. You can add anything you want to it. If we console log the variable anything and we go to our terminal in our current directory with Node installed, you can type node and your file name, which for me is index.js. When you do that, it will log in the console how much I love tacos. Alright, now it's an important time to mention best practices. JavaScript has been around for a long time and has had a lot of upgrades. One of the upgrades is the way we declare variables. Since sometimes you want to store something that doesn't change and that can be very important, they created constant variables which cannot be changed, and they made a variable that is good to use when you know it will change. If you know a variable will change eventually, you can declare it with the word let, which actually makes more sense when you read the code. We can let the verdict be false. The verdict is of course a variable I made up, but false is a new data type for us. And the data type of true or false is called a boolean. Booleans are not in quotes and can only be true or false in lowercase. Let's now console log what the verdict is. Within the console log function, you can see I added a string within quotes to our boolean. Let's run it in the terminal and see what we get. As you can see, when you add a string to a boolean, it puts them together like a sentence. Seeing as how you can't do math on two words, you can change the variable or the verdict, if you will, by simply declaring it again without the let prefix. Now, if we console log, we can see the verdict is more in our favor. Alright, the last basic data type is an integer, or number if you will. You can declare them like every other variable, but since it is a good practice and we won't be changing this value, I'll start it off with the prefix of const, which again stands for constant. What we did here by adding a string with a boolean is a fancy little thing called concatenation. Essentially, you added two variable types together. And as we can see with the word let, they're always trying to make JavaScript more readable for the non-coder. Well, they did that with a concatenation too. And they also created another fancy word. If you use backticks instead of quotes, then put your variable within a $ bracket, you don't have to add any strings. You can just keep writing and write another variable like that when it comes up. Those are called template literals. Like other science though, we don't have to worry about the word photosynthesis means, we just have to know sun good and JavaScript good, so let's keep going. Alright, let's try and break some rules. Remember I said you couldn't change a constant? Well, oh yeah? Who's stopping me? Let's try it. Alright, well, our first error code. But don't be scared. It's like any other directions. Just read the headline and forget about the rest. Assignment to constant variable. Okay, that must not be allowed. To comment out some code, highlight it and Control // or go through a tedious process to put forward slashes in the front of all the things that you want to comment. Let's comment out our mistakes and move on to better things. The last important JavaScript data type is a list. Let's create a list of fruits. To create a list, enclose your variable in brackets and then enclose each list item in quotes, breaking up each item with a comma. Very easy. Lists get a little deep, but we won't get into that here. Just know that they're a very useful data type, and here's what they look like when they're being console logged. Now we're going to do some math. This is where everybody clicks off the video. I'm kidding. Computer math is actually pretty nice. Unlike high school, you don't have to do any of the hard work. Just tell the machine what you want to do, and you're set. You just need to understand the algorithm. Luckily today, we won't be getting into any algorithms, but I will be showing you arithmetic in JavaScript. Alright, we've been to preschool, so I'm just going to rattle these out. You can have addition this way, subtraction, multiplication, division, and a fancy one because we're programmers. The fancy one, though it looks like a percent, is actually called a modulo. Essentially, it returns what remains of a division problem. For example, as you see here, 2 goes into 5 2 times, and there's 1 remaining. 1 is what we get returned when we use the modulo. I'll show you why this is a useful operator a little later on. Alright, now, we're getting into the danger zone. We're learning about loops, which essentially just do something over and over again. There are 2 types of loops, while loops and for loops. While loops are fun because you can accidentally create an infinite loop, which is when your code gets stuck doing something over and over and over again and can't stop. If you let it go on, it'll probably crash your computer. I guess now's a good time to tell you how you can cancel something in the terminal if it won't stop. You simply hit Control-C and that will cancel anything that's happening. While loops are easy to remember. You type while and tell it when to stop in the parentheses. It's when you don't tell it when to stop that it gets messy. After telling it when to stop, you can tell it what to do within the few brackets. We're going to add 1 to the number and console log it until it gets to 10. A neat little trick, if you want to add 1, rather than saying num equals num plus 1, you can say num plus plus. And we'll use another template literal to log the output. Now let's run that. Wow, okay, now that's cool. I'm thinking of all kinds of things I can automate now. The next loop is called a for loop. Though it may seem more complex by looking at it, I actually prefer for loops because they're less dangerous. Start with for, declare a variable, which is often called I in for loops, but again, like any variable, we can name it what we want. Then end that with a semicolon. Tell the machine when you want to stop. We'll stop at 10, another semicolon, and tell the computer how you want to change the variable. Again, we'll just add by 1. And use the template literal to console log the output. As you see, you can use either loop for automating something. Very powerful. Next, we'll be learning about the bread and butter of programming, functions. If you'd consider a loop to be automating a single task, then a function would be writing a list of instructions to automate a bunch of tasks. Anything that you need to do repetitively is probably best suited for a function. If you'll notice to this point, there's actually only one thing in our code we've done repetitively, and that is console log. And the fact that we need parentheses to call it makes it a function. Console log is a function pre-built into JavaScript, and there are a lot of them. Because functions are so important to understand, I'm going to keep it very simple. Like we just found out, a function is a list of instructions. Let's say we wanted to create a list of instructions that can count to 10 for us. To create a function, write out the word function, then pick a name, like a variable, be descriptive but it doesn't matter. We'll name it count to 10, and then we'll add a set of empty parentheses. Then we'll open up a pair of brackets, and inside we write out the list of instructions. Because we just want to count to 10, and we've already done that with the loop. I'm just going to copy the loop into the function. As I said before, to call a function, you use its name followed by the parentheses. Now, if we run our script, you'll see we get the same output as our loop. The power comes from the fact that I can just count to 10 by just writing it out anywhere in my application. The more modern approach to writing functions is to actually store them in a constant. We'll create a function that multiplies any number by 2. So not only will our function automate a task, it will be dynamic. Let's begin by declaring a constant, naming it multiply by 2, and then making it equal to a function. Inside the function, it will take a variable and multiply itself by 2. Then we're going to return the variable. Returning something is specific to functions because generally you are doing something then returning an output. You could write a console log directly in the function, but I want to show you what it's like when you simply return the value of the function. In order to give a function an input and make it dynamic, we have to put the name of our variable or variables in the parentheses here. Then we're going to console log the result of that function. This time we can put any number here we want to multiply, run our script, and voila! We can also make it even more dynamic by making the 2 a variable in the function and adding that variable in when you call the function. As you can see, it's the same result, but we can multiply any 2 numbers together. You can create a function for anything that takes any input. The sky is the limit. Alright, I've got a few more things under my belt for you to learn. The first of which is conditional statements. A conditional statement goes something like this. If you give me some tacos, I'll give you $10. Or else, I'll go buy tacos somewhere else. The main word being if and else. Very simple. If something is true, do something about it. If not, then do something else. To mess with this, we'll actually go up to the count to 10 function, and we'll go ahead and comment out the current console log. Then we'll type if number modulo 2 equals 0, console log number equals even. If you remember from earlier, modulo gives you the remainder of a division. So you're saying if you divide a number by 2 and there isn't any left over, then it's an even number. Up until now, we've used a single equal sign that declares a value for something, whereas using 3 equal signs asks if these things are comparatively the same. After the if statement, we can put an else, and of course if a number is not even, then it must be odd, so we'll console log that. Now we'll run the script, and you can see we created a function that will tell you which numbers are even or odd. Pretty neat. We can also add another conditional on top of that. For example, we can say the number has to be even and equal to 6. If you run this, you'll see it only console logs even when the number is 6. That's because the statement is only true when the number is even and the number is equal to 6. We can use the OR operator as well by using 2 pipes, which are the button just above the enter key. Now it will only console log when either this statement or this statement is true. Alright guys, if you got this far, you should be very happy with yourselves because you have the key to the universe, and now it is up to you to have some fun. Because that about wraps it up for the fundamentals of JavaScript. If you have any questions about JavaScript or think I missed something, let me know in the comments down below. And if you enjoyed this type of shorthanded content, leave a like and don't forget to subscribe on your way out.